Yes, good afternoon to all of you. Yes, I'm audible.
Yes, sir.
Okay, thank you. So I think you got the information regarding ATT at morning in morning lecture. Okay, what is the importance of ATT? Why we are conducting the ATT? Okay, it's a revision of subjects, as well as we need to solve some previous gate questions. Clear? So in order to crack the gate examination as well as competitive examinations, okay, like Transco, Genco, national PSUs, okay, like that. For that purpose, in every semester we are conducting the advanced technical training. Is it clear? Okay, so in this 30 hours advanced technical training, so now I'm going to deal the induction motors. Okay, and I am going to deal the induction motor and transformers. Clear? So today we will discuss theoretical part. Okay, some what is induction motor, how it will operates. Okay, what are the basic equations and so on, etc. So then we will solve some previous gate questions on that. Okay, like this way we will explain some theoretical concept and we will solve some numericals on the that concept. Clear? So what is the syllabus in the gate examination? Can I share the gate exam question syllabus? Do you have any gates syllabus?
No, sir.
Okay, just wait, I will share. Is it visible?
Yes, sir.
Okay. These are the this is the syllabus of gate examination, electrical engineering. So generally we are getting the 65 questions. Is it right?
Yes, sir.
Total we are getting the 65 questions. Okay, out of them some questions are 2 marks and some questions are from 1 mark. Clear? So again in that 15 marks aptitude and 15 marks engineering mathematics and remaining from the core electrical. Okay, remaining marks of the core electrical means 30 marks aptitude as well as engineering mathematics and remaining 70 marks from the core electrical subjects. What are the core electrical subjects? Can anybody tell? What are the gate examination subject in electrical engineering? Anyone? It is on the screen. Screen is visible now?
Yes, sir.
Okay, ये कौन सा है? What is the name of the subject?
Electric circuits.
Electrical circuit. Clear? Okay, engineering mathematics, but aptitude not mentioned. Aptitude is common for all the branches. Clear? So engineering mathematics 15 marks, aptitude 15 marks. Okay, and electrical circuits and electromagnetic fields. Okay, and electromagnetic field means EMF. पढ़ा ना आप लोग सब्जेक्ट अभी इंजीनियरिंग which one अभी लास्ट सेमेस्टर में तो सब्जेक्ट what is that electromagnetic engineering do you know hello electromagnetic engineering I think it is
Yes,
completed
sir.
last semester na okay that is called as we can also call as electromagnetic field clear so electromagnetic engineering or electromagnetic field is same next signals and systems next I think signal system in this semester you are going to study. Is it right? This subject you are going to study in this semester.
Yes.
Okay. Next, electrical machines. So already you have completed the machine 1 and machine 2. Transformer, DC machines, AC machines, synchronous machines, and etc. Okay. And also you know you have completed the power system also. Okay, power system 1, 2, and 3. Next, control systems. Next, electrical and electronic measurement, EMI, electrical measurements and instrumentation, I think. Is it right? Is it right?
Yes, sir.
Okay. So in GATE syllabus, we are calling as EEM, electrical and electronic measurements. Clear? So next, electronic subject, analog and digital electronics. So I have given to the which faculty? Kade sir, SB Kade sir. I think morning lecture completed. I think he has taken one lecture on ADA. Clear? Next, power electronics. So now in this ATT, we are not conducting any GATE lectures on power electronics because this semester is in next semester. Na? In this semester, na? Current semester में power electronics है ना? Is it right?
Yes.
Okay, total 10 subjects are there. One is engineering mathematics, electrical circuits. Okay, electrical circuits are network analysis. Both are same, so don't get any confusion. Some universities are running network analysis. Some universities are calling as electrical circuits. Okay, network analysis like that. But subject is same. Network analysis, network theory, or electrical circuits are same. Next, EMM, electromagnetic engineering, electromagnetic field, signal systems, electrical machines, power systems, control systems. Okay, EMI, measurements and instrumentation, analog and digital electronics, and power electronics. These are the subjects for the GATE examinations. Apart from this, you will get aptitude questions for 15 marks. Apart from this, you will get 15 marks from aptitude. Clear? So I request all of you. So GATE score is very, very important. So please download the GATE syllabus from the net. Okay, and daily you can complete. Daily you should complete 1 or 2 topics from any one subject. Okay, make a schedule accordingly. This week I have to complete this subject. This week I have to complete this subject. Okay, like that we have to make planning and make separate notes. Already they have mentioned the syllabus. Clear? Only you can prepare this one, so you can easily crack the GATE examination. Okay. Is it clear? Syllabus is clear.
Yes, sir.
Okay. Okay, so now I'm going to take the induction motors and transformers. So just today we will start the some operating principle of the induction motor. Okay, now again we will see the one or two questions. Okay, so what is the content in the induction motor, three-phase induction machines, principle of operation? This is the GATE syllabus. Okay, I copied from the GATE syllabus, not from the university syllabus. Please remember. Okay, principle of operation, types, performance, torque, speed characteristics, no load and block rotor test, equivalent circuit, starting and speed control, operating principle of single phase induction motor. So these are the content in the GATE syllabus examination. Okay, from the induction motor. So we will see the some operating principle of the induction motor. What is the function of the electrical motor? Can anyone tell? What is the function of electrical motors? Anyone? What is the function of electrical motor? Function of electrical motor? Preeti? Snehal? Snehal, can you tell? Rushikesh? Kiran? Anyone please? What is the function of electrical motor?
Electrical energy converted into the mechanical energy
Yes,
for various application work.
yes. Okay, simple question. Na? So simply we can, the electrical motor, it is a device which will convert from electrical energy into the mechanical energy, and it will supply to the various loads. It will supply to the various loads. Clear? So AC motors operate on AC supply. They are classified into synchronous, single phase, and three phase induction special purpose motors. Okay, out of all types, three phase induction motor most widely used for the industrial application, mainly because they do not require any starting device. So what we can say here, generally AC motors are running with the AC supply. Everybody knows we require the AC supply to start the AC motors. Is it clear? Okay, again, these AC motors have been classified into synchronous, asynchronous, some special purpose machines. Clear? Like stepper motors, brushless DC motors, switched reluctance motors. Okay, all these are comes into the some special purpose motors. Okay, or special case motors. Clear? So out of all these, the mostly we are using the, in most of the applications or most of the industries, we are using the three-phase induction motor because they will have a advantage of self-starting capacity. Okay, जैसे तुरंत supply दिया तुरंत start हो जाएगा. Okay, no need to any extra device to start that machine. Clear? So working of the three-phase induction motor is based on the principle of electromagnetic induction. So is it right or not? Is it right? Electromagnetic induction. जस्ट वेट हाँ सर मैं लेक्चर में हूँ थोड़ा सा सर अमित यादव नहीं फाइनल ईयर में नहीं okay, sorry for that. So what is the operating principle of the three-phase induction motor? Can anyone tell in simple manner? In simple way, how, who can explain? Who can give the answer? In one line, we can say when three-phase starter winding of induction motor is energized from three-phase supply, a rotating magnetic field is set up which rotates around the stator at synchronous speed. Clear? So means what we can say here. So three-phase induction motor, the operating principle of the three-phase induction motor, we are giving the three-phase AC supply to the stator windings. Okay, we are not giving any supply to the rotor windings. Is it right? Is it right? We are giving any supply to the rotor windings in the induction motor, three-phase induction motor. Can anybody tell? For example, in transformer को primary circuit, secondary circuit, rather primary winding and secondary winding. So we are giving the supply to the only one winding. Okay, we are giving supply to the only primary winding. We are not giving any supply to the secondary winding. Is it right? For example, this is the transformer is there. Okay, so we are giving supply to the only transformer. And here we are connected to the load. Means we are the load devices or load equipments are getting the supply from the secondary winding of the transformer. So here we are giving supply to the both windings or any one winding. कितने windings के दिए है? दोनों winding के supply दिए कि एक ही winding को supply दिए है? Anyone? Anyone? All of you there?
So only one winding.
Yes, only one winding. No? So based on the induction of electromagnetic induction, the current is flowing through the secondary winding. Okay, and it will flow through the load. It will flow to the, or this supply can give to the load equipments. Like the same way here also, induction motor, we are giving supply to the only stator winding. We are not giving any supply to the rotor winding. Okay, based on the electromagnetic induction principle. Okay, the motor will be operates. So I will say here, in simple manner, I will explain. This screen is visible.
Yes, sir.
Okay, starting step क्या है? This is the flow chart. Starting step क्या है? What is the starting step? Starting क्या लिखा मैंने? Three-phase AC supply. Is it right?
Yes.
So this three-phase AC supply is given to the three-phase stator windings. Stator winding में stator circuit में कितना windings रहता है? 3 windings. Okay. Stator is having the 3 windings. Okay, A winding, B winding, C winding, or A phase, B phase, C phase, and so on, etc. Okay, it may be a star connection or delta connection. But simply what we can say, the stator is having the 3 circuits or 3 coils or 3 windings. So this 3-phase AC supply is given to the 3-phase stator windings. After that, what will happening? एक बार windings को supply दिया, AC supply दिया तो क्या हो जाएगा? करंट फ्लो होता है ना, उस वाइंडिंग के थ्रू करंट फ्लो हो जाएगा. अगर उस वाइंडिंग का पर्टिकुलर कॉइल के थ्रू करंट फ्लो होता है तो क्या प्रोड्यूस होता है? फ्लक्स प्रोड्यूस होता है. इज इट राइट?
Yes, sir.
Okay, so whenever the current is flowing through the stator windings of the induction motor, then the flux is produced. Okay, when the current is flowing by the A phase of the stator winding, or if you can take R by B, or A phase, B phase, C phase, and so on, etc. Okay, also you can take small a, small b, small c, whatever you can take. Okay, if for example, if the current is flowing through the R phase of stator winding, the flux is produced by that winding. Okay, that flux is represented by phi r. Like the same way, when the current is flowing through the Y phase, okay, the flux is produced by that winding, that is called as phi y. Okay, like the same way, if the B phase, if the current is flowing through the B phase, the flux is produced by the B phase winding, that is represented by phi b. Is it clear? Up to this point is clear?
Yes, sir.
Next, what will happening? So generally, this is the induction motor. Sorry. Okay, this is the induction motor. Okay, this is the rotor circuit. And this rotor is having the windings or conductors. Okay, this is the rotor circuit. Clear? So what will happening? Whenever these fluxes are produced by the each winding, then it will by these three fluxes, one resultant flux will be produced or developed, that is represented by phi r. Resultant flux produced कैसे होता है? The combination of these three fluxes. We will have some derivations. I think you have studied in the electrical machine subject. Okay. So by interacting these three fluxes, one resultant flux will be developed, and this resultant flux is rotates in the air gap of the machine. Air gap of the machine means क्या होता है? Air gap क्या होता है? What is air gap? Air gap क्या होता है? Please, can anyone tell? Because
between rotor winding and stator winding.
Yes, your voice is not clear. Can you repeat it?
The gap between rotor winding and stator winding.
Yes, exactly. Okay, whatever the space is provided, whatever the manufacturer is provided the space between the stator circuit and rotor circuit, that space can be called as a air gap. Okay, so from these three fluxes, we are getting the one resultant flux. Okay, and it will have some magnitude. Okay, it will have some magnitude, and this resultant flux is rotates in the air gap of the machine. In the air gap of the machine. Is it clear? So what it is called? This is called as a rotating magnetic field. It is called as a rotating magnetic field. Okay. So this it is rotating in the air gap with a speed of, for example, 500 rotations per minute. Sorry, 1500 RPM. Okay, 1500 RPM. So what it is called? Can anyone tell? What it is called? 1500 RPM. The speed of the rotating magnetic field of the three-phase induction motor is 1500 RPM. So then it is called as, we are having one name. Can you remind that? What is that?
Synchronous speed.
Yes, exactly. Okay, this is called as the synchronous speed. Okay, maybe 1500 RPM or 1000 RPM or 500 RPM, whatever the speed. Okay, at which speed the rotating magnetic field is rotates in the air gap of the machine, that speed can be called as a synchronous speed. Okay, next step क्या होता है? So ये step complete हो गया अभी. Okay, next step क्या हो जाएगा? When this field is rotates in the air gap of the machine, then what will happen? This rotating magnetic field cut the stationary rotor conductors. Stationary means what? Rotor conductors fixed रहता है. Maybe rotor is rotating, but conductors are fixed. Clear? So this flux is cuts the rotor conductors. Okay, this flux is cuts the rotor conductors. जैसे rotors conductor को cut करता है क्या होता है? Some EMF is induced in the rotor conductors. Some EMF is induced in the rotor conductors. For example, so if best example I will explain you, transformer. I think you knows very well operating principle of the transformer. Is it right? We are having the two windings. Okay, when the supply is given to the primary winding, the flux is cut the this secondary winding also. Okay, when this flux is the secondary winding, then what will happening? There is a EMF, electromagnetic force is induced across the secondary winding. Okay, EMF is induced across the secondary winding. Like the same way, same principle, when the EMF, when the rotating magnetic field cuts the rotor conductors, the EMF is induced in the rotor circuit. EMF is induced in the rotor circuit. Clear? If rotor conductors are short circuited, okay, for example, if this transformer is having the load, then what will happening? The current is flowing through the secondary winding also. Okay, if it is not a short circuited or closed circuit, the current is not flowing. Okay, if it is a closed path, then the current is flowing. Is it right? Like the same way, if the when the EMF is induced in the rotor conductors, okay, and then the current is flows through the rotor conductors when the rotor conductors are short circuited. Okay, short circuited. Then next step. Okay, अभी कहाँ तक आ गया अपन? EMF is induced in the rotor conductors and then current is flowing through the rotor conductors. Okay, so next step क्या होगा? If the current is flowing through the rotor conductors, then what will happening? वहां पर भी flux produce होगा. वहां पर भी flux produce होगा ना? Flux produce होता कि नहीं होता है? Hello. Hello. Anyone? Are you getting bored? Are you getting bored, please? Am I audible?
Yes, sir.
Are you getting bored?
No, sir.
Okay, यहाँ तक स्टेप तक इधर स्टेप तक आ गया. उसके बाद क्या होगा? करंट फ्लो हो गया रोटर कंडक्टर्स के थ्रू. करंट जैसे फ्लो होता है कंडक्टर के थ्रू, वहां पे भी फ्लक्स प्रोड्यूस होता है ना. Okay,
Yes.
like the same way, the flux is produced by the rotor current and it will interact with the rotating magnetic field. So whatever the flux is produced by the rotor conductors and it will interact with the rotating magnetic field, means which is produced by the stator conductors. Okay, so due to this, one resultant force or torque is created. Due to this, one resultant force or torque is created. So वहां पे क्या होता है? For example, I will show you. यहाँ पर देखो, ये सी फिगर में देखो. Okay, here we are having one conductor. Okay, we are taking only one conductor. Okay, so this is the stator flux, the rotating magnetic field in this direction. Okay, next, so whatever the flux is produced by rotor conductors, that is in this direction. Clear? So here we can see this is the conductor and this conductor is subjected to the two forces. This conductor is subjected to the two forces. One is in this, like this. Okay, another force कौन सा है? यहाँ पर देखो, ये इस डायरेक्शन में, फॉर एग्जांपल दिस फील्ड इज इन दिस डायरेक्शन. ओके, एंड दिस मैग्नेटिक फील्ड इज इन दिस डायरेक्शन. तो ये क्या हो जाएगा? एग्जैक्टली दिस पार्ट. half of the right side of the conductors, what will happening? रोटर फ्लक्स इस डायरेक्शन में है और स्टेटर फ्लक्स अपोजिट डायरेक्शन में, इज इट राइट? दोनों अपोजिट में हो जाएगा ना, राइट साइड ऑफ द कंडक्टर्स. Okay, due to this opposite in direction, these two fluxes will be cancelled to each other. Okay, so but at left side of the conductor, this direction, this stator flux direction, rotor flux direction, both are same direction. So this will be added together. Add होता है, एक side flux cancel होता है, एक side ज्यादा flux create होता है. So means what we can say here, at one side of this rotor conductor is subject to the heavy force, and at one side of the rotor conductors is having the less force. Means यहाँ पे force cancel हो गए पूरे, लेकिन यहाँ पे more force create हो गए. Due to this, then what will happening? The rotor is trying to start in this direction. Okay, due to this, the rotor is trying start in the direction of the rotating magnetic field. Is it clear? So when the one conductor, एक conductor के example है, so like this same way सभी conductor कैसे रहेगा? Okay, one side of the conductor is the flux is cancelled to each other, and another side of the rotor conductor is having the more force. Okay, due to this force, the rotor conductor is trying to rotate in a particular direction, that is same as the rotating magnetic field direction. Clear? So like that way, when the force is created due to this interaction of these two fluxes, rotating magnetic as well as flux created by the rotor conductors, so the rotor conductors are subjected to the heavy force, and due to this force the torque will be created. Due to this torque, the rotor is trying to start rotate in the direction of the rotating magnetic field. This is the operating principle of the three-phase induction motor. Is it right? Everybody understand, please? Everybody understand, please?
Yes, sir.
Operating principle clear hai? Okay, now I will ask the questions. Just see here. One more we have to see here. Okay, when the motor is all this theoretical part I have explained in this flow chart. Okay, so theory में समझ में नहीं आया, इसलिए मैंने flow chart ड्रा किया था. ये flow chart में easy है ना समझने के लिए? Okay, so when the motor is excited with a three-phase AC supply, okay, then three-phase stator winding produces a rotating magnetic field with 120 degrees displacement, a constant magnitude which rotates at synchronous speed. Okay, this changing the magnetic field called the rotor conductors and induces the current in them according to the principle of Faraday's law. Okay, the electromagnetic induction. Okay, according to the Faraday's induction law, when the EMF is induced, the current is flowing through the rotor conductors. Okay, so as these rotor conductors are short circuited, then the current start to flow through these conductors. Okay, already we have seen this step in the flow chart. In the presence of the magnetic field of the stator, rotor conductors are placed. Okay, and therefore according to the Lenz's force principle, okay, according to the Lenz's force principle, a mechanical force is acted, a mechanical force is created. Okay, due to this mechanical force, okay, okay, whenever this force is created on the rotor conductors, then what will happening? Summation of all forces means each rotor conductor is having some force. Okay, summation of all these forces, the torque is created. Okay, the torque is created. Okay, due to this torque, then what will happening? The rotor is try to rotate in the direction of the rotating magnetic field. Is it right? Okay, here you can ask the question, Lenz's force principle क्या होता है? Related to flow of current or related to torque or related to electrical force? Related to torque है ना? So as per the Lorentz force principle, so means the mechanical force is created. Okay, it is not related to the currents, but Faraday's law. Okay, when the EMF is present, the current is flows through the some circuit. If that circuit is closed path, clear? Okay, you can go through this operating principle. So all these we explained, we have seen this one. So here you can see leakage flux in induction motor is leakage flux in induction motor is leakage flux induction motor क्या होता है? What are the options? Can anyone tell the answer? Am I audible? You can tell any one answer. If it is wrong, no problem. Because it is this question is came in gate examination. If you know the operating principle, then only you can answer this question. Anyone? Tell any one answer, no problem. If it is wrong, no problem. Anyone, please give the reply. Preeti, Priyanka, Manjali, Aishwarya, Raut. If you are not giving the answer, so this is the interaction. Advanced technical training is nothing but an interaction session. It is not a theoretical subject.
Option A.
Option A. Option A is the wrong answer. Because I will tell somebody is giving the answer option D. Yes, is it exactly right answer? Because if we are having the transformer, okay, when the current is flowing through this winding, okay, the flux is produced, and this flux is cut the secondary winding also. Okay, ये जितना flux cut करेगा secondary उतना EMF मिलेगा अपन को. The induced EMF in the secondary winding, the magnitude of the induced EMF in the secondary winding is based on the how much flux is cutting the rotor secondary winding. Is it clear? If यहाँ पर क्या होता है, some amount of flux is wasted only like this. This is called as a leakage flux. ये flux secondary winding को cut नहीं करता है, यहीं पे rotate होते रहते हैं. उसको बोलते हैं अपन leakage flux ना. इसको बोलते हैं leakage flux because it is a wastage. Okay, so whatever the flux is created by the primary winding, it will, and this flux is not touches the secondary winding. That flux can be called as a leakage flux. It will be wasted. So as an electrical engineer, we have to try to minimize this leakage flux. Okay, otherwise the efficiency of the transformer is going to reduce. Otherwise the efficiency of the transformer is going to be reduced. Losses ज़्यादा हो जाएगा, efficiency कम हो जाएगी. इसलिए leakage flux को reduce करना जरूरी है. क्योंकि लीकेज फ्लक्स से क्या होता है, जो whatever the we are getting the magnitude of the secondary winding, that will be decreases. Okay, whatever the EMF we are getting at the secondary winding, that magnitude will be decreases. So that's why leakage flux is not touch the secondary winding. So like the same way here also, the leakage flux will not touch the both windings. अगर both windings से touch हुआ तो उसको leakage flux नहीं बोल सकते ना अपन. लीकेज फ्लक्स नहीं बोल सकते ना. जो फ्लक्स क्रिएट हुआ है वो दूसरे वाइंडिंग को टच नहीं करते, उसको बोलते हैं अपन लीकेज फ्लक्स. सो दैट्स व्हाई द flux that links the stator winding or rotor winding, whatever the leakage flux is created, it will link the primary winding, or whatever the leakage flux created by the secondary, that will link the only secondary winding. Okay, but this leakage flux will not touch the or will not cut the both windings. Clear? This is the D is the right answer. Is it right? Is it right or not? Okay. Next, next question. I will explain this theory. No, sorry. What we can say? Equations. I will explain tomorrow. Only we have 5 minutes. So one more questions we will see. So I have not derived the torque equation here, but we know the one formula. We know the one formula. What is that formula? Motor torque Tm is equal to 3 by 2 into omega b into xs plus xr dash whole square into v by k whole square. And to motor torque at the base speed. Tm is nothing but motor torque at base speed. Base speed means whatever the motor is running at the base speed. The motor base speed is 1500 rpm. Okay, when the motor is rotating at 1500 rpm, and whatever the torque is produced, that torque can be called as a motor torque at base speed. It is clear. So these two are the different. So 3 by 2 omega b is nothing but motor speed in radians per second, motor base speed in radians per second. Okay, into xs plus xr dash whole square into v by k whole square. Xs is nothing but stator reactance, xr is nothing but rotor reactance. Okay, divided by 3 by 2 omega b xs plus xr dash whole square into v square. So यहाँ पर क्या हो जाएगा? V square will be cancelled. 3 will be cancelled. 2 omega b will be cancelled. Xs plus xr dash whole square plus xs dash xs whole dash square plus whole square is cancelled. So remaining term कौन सा है? Which term is remaining? Which term is remaining from this equation? Tmb is equal to 1 by k square. सभी कैंसिल हो गए तो ओनली k टर्म इज रिमेनिंग. तो tm by tmb is equal to 1 by k square. Clear? So here k is nothing but what is the k? K is nothing but what? What is the k? F by F rated. F by this is the frequency ratio. Okay, this is the actual frequency. This is the rated frequency. Okay, k is nothing but frequency ratio. So from this equation, what we can say here? Okay, from these equations, what we can say? So Tm into k square is equal to Tmb. Okay. So from this above equation, the maximum torque is inversely proportional to the frequency squared, and motor torque remains constant. Clear? So means what we can say here? Motor torque at base speed remains constant means Tmb is constant. Tmb is constant हो तो क्या लिख सकते हैं अपन? Tm proportional to 1 by k square. 1 by k square. So means this is the frequency ratio. The motor torque is inversely proportional to the frequency. Inversely proportional to the frequency. Here k is nothing but frequency ratio. Okay. F upon by F rated. F upon by F rated. Is it right? So from this equation, can we solve one question? Can we solve one question? So here, for example, the rated frequency for motor is 50 hertz. Rated frequency, F rated is equal to कितना दिया उन्होंने? F rated is equal to कितना है? What is the F rated? How much he has given in the numerical? F rated कितना दिया उन्होंने? How much? Please tell me.
50.
50 hertz. And maximum torque at base speed is equal to maximum torque at base speed TMB is equal to 100 Newton meters. Okay. If the motor is now operated at 75 hertz, okay, this is the rated frequency and operating frequency is 75 hertz. So before we have written the equation K is equal to F by F rated. Is it right? F by F rated. So F rated is nothing but rated frequency. For example, अगर कोई एक डिवाइस अपन को मेंशन किया नेम प्लेट में, उसका रेटेड फ्रीक्वेंसी 50 हर्ट्ज है, तो लेकिन अपन उसको 60 हर्ट्ज से भी ऑपरेट कर सकते हैं, 75 हर्ट्ज से भी ऑपरेटिंग कर सकते हैं, या 35 हर्ट्ज से भी ऑपरेटिंग कर सकते हैं ना अपन. वो वेरिएबल हो सकता है. अगर फॉर एग्जांपल एक डिवाइस का वोल्टेज रेटिंग से 230 वोल्ट, लेकिन कभी कभी अपन 200 वोल्ट देते हैं, कभी कभी 250 वोल्ट देते हैं, कभी कभी 150 वोल्ट देते हैं. दैट इज कॉल्ड एज ऑपरेटिंग वोल्टेज ना. Is it right? But rated voltage is 230, but operating voltage is how much we have given. How much we have given. Clear? So here rated frequency is 50 hertz and operating frequency is 75 hertz. Then what will be the maximum torque? TM find out करने का. TM find out करने का. So he will give the options. For example, 50 Newton meters, 60 Newton meters, 100 Newton meters. He will give the options. Okay. So for example, I will give the options. You can use chill. Option A is equal to 80 Newton meters. Option B is equal to 50 Newton meters. Option C is equal to 44.44 Newton meters. And option C क्या लिख सकते? Option D क्या लिखेंगे अपन? Option D. Option D is equal to 60 Newton meters. Okay. So what is the right answer? First of all, we have to check whether it will be increase or decrease. वो check करना है. Okay. So here, what is the formula? We know the formula. What is the formula? अपन क्या formula बताया था? Formula क्या बताया था? TM is equal to maximum torque find out करना. TMB by K square. ये है ना? From these relations. ये relations यही लिख सकते ना अपन. One student is given the right answer, exactly right answer. Who is that? Harshavardhan. Harshavardhan?
Yes, sir.
44.44, right answer. So we have to check. So maximum, this is the formula from this equation. So अपन को TMB मालूम है क्या? TMB has given ना? दिया ना TMB कितना है? हर्षवर्धन
100.
100. के मालूम है क्या अपन को? के मालूम है क्या? के फाइंड आउट करना है. के इज नथिंग बट ऑपरेटिंग फ्रीक्वेंसी अपॉन द रेटेड फ्रीक्वेंसी. ऑपरेटिंग फ्रीक्वेंसी कितना है? 75. क्लियर? 75 divided by
50.
what is the value?
1.5.
1.5. So now we know the value of k. So we can easily substitute in this equation 1.5 whole square. 100 upon by 1.5 whole square. What is the value of this one? Is it right? Is it right?
Yes, sir.
Okay, means पहले अपन इस इक्वेशंस क्या बोल सकते अपन? If the frequency increases, the torque will be decreases. Okay, the frequency increase होगा, the torque will be decreases. So ये प्रूव करना है. तो यहाँ पर 50 हर्ट्ज से 75 हर्ट्ज इंक्रीज हुआ तो टॉर्क क्या होना चाहिए? डिक्रीज होना चाहिए. क्लियर? सो व्हेन द motor is operating at 50 hertz, the torque is 100 newton meters. When the motor is operating at 75 hertz, the torque should be decreases. Decrease होगा 44.44 newton meters. Decrease हुआ ना इधर? Decrease हुआ ना? Means when the operating frequency of the motor is increases, the torque will be decreases. So means he can ask the anyway questions. Okay, if the motor frequency, operating frequency is increases, then what about the torque? Whether increase, decrease, or constant? Okay, or none of the above. So answer is क्या? Decrease. Okay, if the operating frequencies decreases than the rated frequency, then what about the torque? Options: increase, decrease, constant, or none of the above. Are you got the questions? This question is understand all of you? Please, anyone? Hello? Anyone, please? This concept is clear? Torque का है? Because here I am not going to derive the equations because this is the technical training question. Simple, short में बताना पड़ेगा अपन को. Okay, so we are not dealing the subject. So that's why I am not going for the derivation part. Okay, so one more question I will give. Same way. If the, just I will orally tell, listen player carefully. If operating frequency is 50 hertz, okay, operating frequency is 50 hertz, and the rated frequency is 75 hertz. Exactly opposite. This is the operating frequency, and this is the rated frequency. Rated frequency. Then what about the torque? What about the torque? Torque क्या होगा? Increase, so I will mention like this. Torque क्या होगा? A is equal to increase and B is equal to decrease and C is equal to constant. Just understand like this. Okay, increase, decrease or constant. इसमें कौन सा आंसर राइट है?
Increase.
Increase, because operating frequencies decreases. Operating frequency decrease होता है तो क्या हो जाएगा? Torque increase होगा. तो obviously the torque is will be increases. Clear? So means in any way they can ask the questions. Okay, are you got the point? Just wait, I will take the attendance.